So we, in the Rholang lab, we went over just some basic contracts, and we slowly built them up into something that would be usable as an account, not necessarily a wallet, because for a wallet you would still want, to verify. You don't want just anybody to transfer money out of your account and other things. Like anybody can send you money, but so we're gonna start simple, and we'll just build. We'll work that example forward. And if you have any questions at any point, go ahead and stop us. I'm going to draw a line down here because I want the vertical space. And, all right. So the simplest contract that that you might want is a cell. And for clarifications, you can think of a contract as a function that produces a process or a templated process or a parametric process, whatever you'd like, but it accepts arguments. And in this case, we're going to accept 3 arguments.
There was a little bit of preface, which was Kenny we were also talking about the auction contract, and Kenny got to these 2 lines and said, what if one of them happens and not the other? Or the other way around?
Yeah, and it was a switch, right? Oh, select. That's right. And this should be familiar. So the get will give us a return channel. And at the same time, if we're going to get, we need the value. We need to lock the state and get the state. And then we're going to send the state that we got, and in parallel we're going to put it back. And we're also going to rerun the cell. So this cell is a process, and if we don't rerun it, it's basically a single-use cell. And we want a multi-use cell. So in order to do that, we invoke the same contract with the same channel arguments. All right. What?
Looking around for furrowed brows.
Okay. Yeah. And if, so this actually, I found this part of it very straightforward. And then we get to the slightly harder case. Yeah, value to set. And the reason we take this is oh, sorry. Thank you. Left. So the reason that we read this out is not that we're going to use it, or it looks like we're not going to use it. Or yeah, in this case, we're not going to use it, but we read it out because we don't, if we're going to set it, we don't want anybody else to read the old value. So at the same time we get the value for set, we need to also read, basically take it. So if you're from... Yeah.
I don't think so.
For this part, yes.
Oh, sorry, yeah, you're right.
We're going to tweak this over and over until it becomes the thing that we want. But for now, yes. We're kind of using it like an MVAR in Haskell, if you're familiar with that. The obvious thing with the bug, and I'm going to write the bug and then you can come fix it. All right. And then lots of close braces, but we're going to leave it blank. So why don't you go ahead and show me what the bug is that I've written and how you resolve it.
Okay, I'm going to pause just for a second. Does the bug occur to anyone else? That's that's one way of looking at it. I'm not sure.
Oh.
Any other thoughts on what the bug is?
So Mike didn't have a mic. So he said that you may set twice, and that's prevented by the channel basically acting like a
lock.
A lock, right? Like, or the state channel acting like a lock.
Correct. These two are not ordered, but these two things are both or nothing. So at the same time, somebody's set message came in, we locked up the state. Any other bugs occurred? At the same time, V came in, we locked up the state. We read out the state from the state channel. Right. Well, right. You can't read the one that was there. Can't write a new one. I suppose you can write a new one.
The bug is subtle. It's basically someone may read the old state.
That might be a different thing than what everybody else is talking about. I don't know if.
No, they actually interact.
Okay.
So walk it through. Here, I'll walk it through. Actually, one is that you're missing the parentheses. That's true. Yeah.
No,
We said we're going to get this. We left those off. We're going to get to that. It's going to change it. Fair enough. Okay. So let them. This is running parallel with this one. So let's say this is really fast, right? So it comes up, and now it can start doing gets. And it can also start doing sets. Ah, that's a good point. That's a very good point. That's a very good. Yes, you're absolutely right.
At that point in time, that second it's locked, right? Because it's trying to mutate something it can't mutate, right?
Right. Oh, you've done it. You've. No. That's exactly right. So you're correct that this is locked. So if this one comes up, the get is going to be locked. But now suppose that there was also another set in between.
Well, you have ordering on the set too.
So. Yeah. Right. Right, but notice what will happen, right? So now we have, and I mean, this is the way I originally wrote it, and I thought it was totally fine, except when we were talking, I noticed this little issue. Okay, so the real issue is, suppose we have a set come in, and then a get come in. So now we have two sets racing, right? And we have a get. Right? So which one of these is this one going to get? Yeah. You might care. Yeah. You might care. You might care. So what do you do? What was the solution?
I don't see how that's a problem.
It's not necessarily, but they have a proposal.
Well, you can imagine yourself as a caller trying to do something like this, and not wanting lost updates. You can imagine yourself, for example, Kent was working on the auction contract and he wanted to make sure we could,
Are those sets and gets all in par with each other, or? Oh, okay. In that case, if they're all in par, then who knows what order they're going to happen in? But
So yeah,
if you don't want them in par, then you need an alert back from the cell that says when this state has been set, so you can synchronize on it.
so go ahead and erase the line.
So,
this one?
No, erase that line.
so it's simply not
Yeah.
possible
You're gonna need to
to
add
wait
something
for
above it.
the cell to update, and you just send all the things, and whoever wins, great.
This is really pedagogical.
Okay.
I'm also going to squeak something in here because we ended up,
Not yet, not yet.
sorry. Oh, right. Okay. So, so that construct wasn't on the list of four Rholang things this morning, but it's a short syntactic sugar for state is a new process. New channel. Anyway, you get to introduce new names this way. So, and we're going to stick the incoming value there. Right there. And in parallel, this might be the whole solution, or I might not be remembering all of it. And to continue, set is the same, set is the same, and the state is the new one.
So now this doesn't actually change the fact that it was originally correct and I made a mistake. Because it was originally correct. This won't actually change. It will still force the issue, but it doesn't change what happens with the new get set. Yeah. Do we agree?
We need an explicit action.
Oh. We have to act explicitly.
Okay. So this is part of the solution.
You can put an act on there, and that's the next piece of it. So that's okay. I mean, no, you don't have to modify that because we're gonna do that next. So do we agree that this semantics is ISO to the previous one?
I think so.
In other words, it fixes nothing?
It fixes nothing because there wasn't a bug in the first place.
Okay.
It's useful to know.
Yeah, it worked as intended. I thought I saw a bug, but the bug wasn't there.
Yeah, if you're doing get in parallel with set, any reordering of those, because par is commutative, is valid. So any ordering of setting the state and then getting. So any reordering of getting and setting is valid because par is commutative. And so even with this one, you're setting a new state variable, but the order in which those state variables are set is arbitrary.
So why don't I go ahead and move on to the next one?
Question that might help us. So are these, this whole contract here, is that an atomic operation?
That's where we're aiming.
Yes. This
Okay,
is
because it does, whether it's an atomic operation changes the, but so I don't quite understand if that's atomic, how it can,
So
so,
the portion that is atomic is both of these. Either both of these occur or neither occur. And that's implemented via the tuple space. So if we get a request on the get channel, we will also at the same time atomically get the state and lock, basically take the state from the channel. We have to get both or none. And similarly, if we get a set message, we also get the state or nothing at all. So we either get both or none.
thinking. Okay, got it.
All right. Well, I'm gonna rewrite this line. No. I'm going to do the thing that was pointed out because it fits in our tower of things
Elaboration.
anyway. So we're gonna get a tuple out. We can change this underscore next. So, and now if you want to sequence the, if you want to do your gets after the set, you now have a channel where you can tell that the set has now occurred. Do you want to do the modify?
Actually, I don't understand because the act is not ordered with respect to the state, right, and cell. So how is, I don't understand, can you walk me through how the act works?
That's true, but they all three exist at the same time. So when you go to read a value from the state, if you wait on act, then you know that this,
Well, what you know is that this has happened.
yeah, the state, the old state has been removed when you get the act, and that is the most important part. Doesn't matter if you read the act first and then it goes in, or it goes in and then you get the act. That's fine, as long as this has occurred already.
Okay.
Anyway, it's not as important. Let's move on to the next piece.
Okay. Okay. We're getting closer to something that's, there was a question about double spend. That was also in our conversation, so we were headed in that direction.
I think the first question was about read, modify, write.
So now you want to,
Right.
yeah.
Isn't the next one integers greater than 0?
Yeah.
No, the next one is well, we did them both at the same time.
Right.
But the next one is read, modify, write.
Then I don't know.
Okay.
I don't have that one in my brain.
I'll do read, modify, write. So, if you imagine, so I'm gonna, so. So, something like this. Who can tell me or can anybody spot a problem with this? It's a return channel. Oh. Oh. Hold on. It's sorry. It's this. Sorry. R. Oh. Anyway, forget that. Just skip that for now. Like, it doesn't matter. We can get it right. It's not relevant to the point we're trying to make. Oh. Right, like, and assume we do, like, we're using the old one. Is that colon meant to be a curly brace? Yeah, sure. Yeah. So the problem as I see it is you don't know what's off here running and what else might be sending on the get and set channels in between this and then this. So this may be updating a stale value.
Where's this run? It's running in parallel with the instance of the cell that has get set.
Yeah. Yeah, so yeah, I happen to know the channel so that I can communicate with the cell. And so we wanted to have an atomic modify. And in this case, we wanted specifically just an atomic increment or decrement. So why don't you go ahead and do that? So you change the name to like increment or something. So just on the right, you can leave this. It won't hurt anything.
So one thing to mention is that the arithmetic sublanguage, we introduce structural equivalence so that x plus 5 actually does reduce before being sent to set, as opposed to generic processes that don't reduce in set position.
So for the total functional language.
So I'm going to change the cell contractor. I'm going to make another cell contract where it gets the same, so I'm not going to repeat that.
Oh, you have a select, and you're just going to leave the same get case.
Yeah.
One thing that comes to mind is if this is the sort of hello world of row calculus, and it's so hard to get right, how do we expect new programmers to be able to do that in the absence of a relatively strong type system?
Well, I wanted to talk with you and Kent and Kyle about just rather than doing the ladle-based behavioral types, just do the ones in the namespace logic paper, because that's very straightforward. Yeah.
You're going to want to name the state value.
Yeah, well. Sort of do the edits long.
Okay.
Really? Somehow I lost a trick.
No, it just turned out that trick wasn't necessary. It was kind of cool, but
Well, okay, no, but it is an important trick for other things.
Yeah.
It wasn't necessary in this case. 'Cause
Okay.
we're stealing it from this.
So I haven't changed anything yet. I changed the name of this channel to modify, but that was just alpha different. Okay, so I haven't done anything yet. So this has the lost update bug, right?
No.
No, that if I read this thing, somebody else does something, and I write X
Oh,
plus
yeah.
5, and then we get a lost update because somebody else did something.
Yeah, yeah. D needs to be at comma D.
Right. Oh, we've already gotten that far, haven't we? Okay.
I'm getting the audio, but it's cutting out every few seconds for some reason. What if I have my thumb on the mute button? I don't think so. Just check. Oh, you were good. This mic's good. Okay.
Right. So in this case, I'm going to go ahead and change this to balance.
Yeah.
So this is part of that's basically the feature that we're interested in. We'd like to be able to change the thing. And so now the caller is going to do modify with 5 instead. So now the read modify write is going to happen inside the contract, so there's at least not that sort of lost update. And I'm trying to figure out, seems like there was more to it than this.
No, this is a good stopping place, and then why don't I pick up?
Yeah.
So,
Oh, and on separate lines, there's not a semicolon between, like in lots of languages, there's a vertical bar in between. So that's also twists your head a little bit.
So in this one, do you not get the lost update because successive editions commute with each other?
you don't get the lost update because the update occurs while the state is unavailable. Right, like in here, right, like this, after the get, the value is put back in the state. And so somebody else can read it. Whereas here, the modify basically occurs, in a sense, while it's locked.
I see.
Yeah, so I guess the get here is kind of irrelevant, right?
No, it's relevant for the example, but here it's like it's like this get actually doesn't include this update. So the next thing that we wanted to do is we're going to change the name of this. I'm going to go ahead and leave this version. Can I go ahead and erase this?
So actually, the previous one here with the set bug, had that been named add, and the only thing you could do with it is, oh, never mind. No, that won't work. Okay, sorry.
All right. All right. Okay, so we're going to change the name of this to balance and get and state, and we're going to do select and we're going to leave our get case and the logic copied over, and then we're going to call this R for return. Fine. Okay, so now if So if we want it to go true, or if we,
It would really be a match case, but it's okay.
okay.
This is syntactic sugar for match case. Do people understand that?
Okay. If we don't have
You
syntactic,
can always do ifs and match cases are.
so we're going to write. Oh. And the else case should be fairly straightforward. All right, do you want to go ahead and, on this side, go ahead and add the transfer argument?
So this doesn't have the next feature, but at this point, I think it prevents double spend. What would happen if we tried to double spend?
So there's a resource that's sitting inside the state, and currently, so there's a resource sitting inside the state, and that resource is at least a ring, yeah. And you can't update it. No, I guess it's at least a group. And you can't ask to update it beyond 0. So double spend would be taking that value and taking it below 0.
Go
So
ahead.
you can increase, you can spend it, and once you're down to 0, you can't spend anymore.
So sorry, does that capture double spend for sure though? Like, couldn't I get, 5 rev from one person and 5 rev from another person? So I've got 10 rev total, and then I can spend 5 twice, but does it care about like which, like if I say that the first 5 I am spending twice, like I explicitly say that the one that I got from you, I'm going to then take that and give it to 2 different people, but I still have I'm not violating this condition basically.
That is a good question. And it's a scope, turns into a scoping issue. And I'm trying to remember if there's a straightforward way to,
So
go ahead.
no, unlike like in Bitcoin where like you're spending like actual bills like that you can point to, here you're just adjusting bank balances. Right? Like if your bank balance is $10 and you write 2 checks for $5, that's not a double spend. That's just spending $5 twice. So like you really only have to worry about the case where you empty your account and then you empty it again and then you abandon it. So that's really what you're preventing here.
Yeah.
Well, but
overdraft.
yeah, if you have a numeric balance representing, that's the only kind of double spend you have to worry about.
Yeah, we don't really have coins here.
The way you might be able to get around that is if you could do something funny with the consensus on the transactions that are associated with the COM events here, and that might enable you to run get some weird trace on some of the validators, right? So some of the validators see some of the spends, and other validators see other spins, right? And what the consensus algorithm guarantees is that that doesn't happen. All of, if you achieve consensus, they all are in agreement about the transactions that are against this contract.
So why don't you go ahead and do transfer?
Okay, so this you can you can make this number go up and down, but to make this go up, you don't have to give up anything. So what we like to do is to make it so that in order for this one to go up, somebody else's has to go down. And I'm going to sort of start in the middle. And we might start with R and D as before. Just a minute. And I could write a bunch of this stuff down, but in order to get the feature we're interested in, we have to have the other guy give us some rights, basically, to scribble in his end, in a way. I'm trying to remember if it's three things. Right. Make it a little bigger.
We also need a return channel.
Yeah. At some point, I'm going to want to do state. But no, it's match case, whatever. Return happy. And do I end up doing this? I don't think we did that before. Seems like it has to be, though.
That's true, but remember that that bottom one is expecting a return channel as well, and may fail. I don't know if we did. I can do it if you're. So you're going to end up with a pair
Go
of.
ahead, because I think it's going to be quicker in any case.
Okay. So you're going to end up with a pair of nested ifs. You can also you could also just say balance has to be positive, and we fail if. But we'll do it. It's similar. You need a double nested if anyway. Case true.
Oh, you can get rid of nested ifs a lot of times if you do both checks and pass that into a pair.
But we only want to do this we only want to try the. Yeah, they have. So we do new R in. Oh yeah. R minus D in parallel with in parallel.
Are you sure you want R to be the return channel again? It's a new. Oh, new R. Good one.
Yeah, I mean, I can call it RT if you like, just for pedagogical. R, so R, that's right. Oh yeah, I do need an RT because I have to do. Okay, so get modify transfer as state. So this is the interesting case. The others all basically just rebuild what we tore down. And I'm sure, right? Like, so there's a case false from R, and then there's a case false from the check. They're all basically uninteresting.
So walk through what happens.
So what happens is we do the check. If our balance would not be decreased below 0, so that should be. Then we can go ahead and proceed with contacting the other wallet. You can think of it that way. We send a return channel and a negative amount to that channel, and then we listen for the result from RT. Oh. If it's true, then we go ahead and send true on our return channel. We update the state, our state, with the increased balance or the modified balance, and then we continue running the same balance. And so one of the things that we ended up talking about was that while you would need these channels, you would want only to expose, you wouldn't even want to expose the transfer channel because someone would, as soon as you did, you'd find your wallet empty. So instead you might wrap this in, like, with a check that says, is this going to make me richer? If so, it can proceed. And you can hand that out, right? Like, anybody is free to make you richer. So you would wrap that, and then you would associate that wrapped channel with a public key where people could send messages.
What does wrapping look like in an object-oriented thing, I would have an object that closes over transfer. But closing over something, you're still sticking the entire continuation on the blockchain and it's public. Anyone can inspect the channels that you're closing over.
So no, my suggestion was that channels that are closed over are not. So basically, you can see them, but because they aren't they aren't made public, it doesn't matter that you can see them, right? Like, they're just present as like references to other things on the chain. They're not public keys, and only if you want something to be available to be external. If you want external actors, then you make an essentially a public channel that people can send messages on. And so what you would do is you would produce such a public channel that wrapped this private transfer channel, and along with a process that did the check that your balance was increasing, and then you would only then would you feel safe publicizing this channel as something that external actors could interact with.
If I've understood you correctly, you have a new scope over that channel that's available within the contract scope, but not available outside. And then you have a link with a public transfer channel that has access into that private channel, right? So then the new scope hides the actual channel, so that's you can see that the code is going to use a fresh channel, but you don't know which one that is.
But in row calculus, new is compiled down to row calc. Right? Row calculus doesn't have new. Are we suggesting introducing a fundamental new operator into Rholang that isn't compiled down?
No, you can make that compilation process as unguessable as you want.
I think Mike's point is you don't have to guess it if you can see the results.
No, you don't. Think of it as effectively an oracle. You don't necessarily know that when you run this at this time, you're going to get this answer. Right? So you can make it. You can include salt. You can include non-determinism, consulting oracles. You just have to make sure that you get a channel that's at least different than all the channels inside the scope of your computation.
But if you're relying on oracles, then you also need to get consensus on the value that the oracle produced, right? I mean, one possibility is that we introduce an oracle and say, well, this has to produce randomness. We provide it as a certain kind of channel name or thing that's local to the node. We know it produces randomness, and since randomness is exchangeable for randomness, when I'm running it locally, it doesn't matter what this thing is, therefore nobody can guess it. Okay, so that's something that's not we haven't seen before in the requirements for the VM.
Okay, fair enough.
Yeah.
Fair enough.
Yeah, it kind of
from node to node to node to node, because of alpha equivalence, they don't all have to agree on that private name. It just has to be private within that local copy.
Oh, that's a nice property.
Yes, but we're relying on the implementation satisfying alpha equivalence. So it's something that the node software has to provide in order to ensure the security. So to be information theoretically secure.
So this process then is listening. So if you invoke balance as a contractor, right? Like you say, please run this, and here's some rev to store it and run it for a while. You now have on the chain a listening process, and you can see where it's listening. Do we want to say that those? No. Like if it's listening on something public, you can see the public keys, but who cares?
Right.
You just need to say, well, in order to send a message on this, you have to sign it with a private key.
With the private key associated with the public private key pair, exactly.
So using your example of what Ethereum did wrong in generating random numbers, we can have part of the deployment process involve getting a random number that none of the individual nodes can predict and have that be part of the compilation and deployment of this contract that the resulting thing they all agree on is something none of them could have predicted. Therefore, you can't take a public channel and hope to embed it in your code and have it show up.
That's true, but can you can you view the result after the fact? Would be anyway. We can table that.
Yeah, we should. But I think it's important to recognize that there's this notion of as you go from layer to layer to layer, you're introducing additional scopes, and those scopes are what's controlling your visibility, right? And you can the way I was describing it to Kent during our talks is you can think of that scope as introducing the audience to which you're publishing access, right? Does that make sense? Does that still make sense? Oh, what is your question? Oh, okay. All right. Well, then we'll come.
So it kind of makes sense that using scopes, you may want to say some, like external actors just can't interact with these names even if they know them.
Right. Yeah, exactly.
So I see how this works, and sounds like what you said pretty recently was, all right, you invoke this contract, you pay a little bit of rev to get it to go, right? It does one of these things, and then runs again. Who pays for the runs again part? So when you...
So whoever instantiated that they're supplying a certain amount of rev, and they know that rev is going towards running it again. You can make it unrunnable, exactly.
So presumably, like you would have, in addition, you would have some rev over here, and then the rerun would run with the same rev, or deduct the correct amount and run. And so when you instantiate it, you fund it essentially. And yeah, we'd have to work out some schedule for like if something like this is sat for 6 months and no one has said anything on the channels, right? Like, well, what do we do, right? Like, how long do we expect that to be around before we just GC it? All right. I think that's wrap up. Yeah.
Oh yeah, I mean, for conclusion, I was just wondering if I should show how this will be used.
Yes, please do.
Quickly, so the idea is that the transfer contract that we've built up here is something that we don't want to allow the user to be able to tweak, essentially. This is going to be like a system level contract, so to speak. And I just want to show a quick example of how that will be used. So I'm just going to define, this is within
Sorry, I don't understand why it has to be a system contract.
Oh, because otherwise you can these are implementing accounts. Yeah, like you can create your own logic, right? Which is not like, what if, for example, instead of adding plus D, you add plus 2D? Then you increase the supply of revs, and we don't want that, right?
You have to have some kind of system level contracts to make sure that rev is utilized correctly in sends and receives across blockchain channels.
So I agree that you would want at least one system level contract that looks like this, but I don't think they have to exist. I think you should have some way of saying, I'm only interacting with one that looks like this one that I verified. And so you should be able to, users should be able to implement the same logic to transfer other assets. Yeah, and they can say, oh, well, I've verified the transfer logic, it's fine.
We talked about the bang and the for operations. They're going to be no, but those operations are implemented relative to these system contracts in addition to the Casper contracts, because otherwise you're not getting the right rev decrements.
No, I just meant you could put any Rholang code you want in the blockchain and it will go, right?
Yes.
Yeah, so, I mean, if you put this contract, even though it won't send rev around, it will send integers around.
Oh yeah.
Okay.
Yeah. Sorry. But yeah. So you can take the stuff that implements rev and move it up a level. Yeah. Exactly.
So what I have here is sort of a snippet from the auction contract. And essentially, we're just doing the withdraw function because it has what is sort of interesting right now. And the idea is that we first, let's oops, sorry. I should have abbreviated this. Maybe I can do that now. So the withdraw takes in two parameters, I'm going to say message sender and the return channel. And we essentially we have a table that's on the pending returns channel. We just call this pending returns. And what this table does is it keeps track of all the amounts that this contract owes the users. Because this is an auction contract, so there will be many users that have bid into this contract that didn't win the auction item. And therefore, now the contract owes them back what they've bid. And this is all kind of mapped on this table. And so what we're checking here is to see that the message sender who is requesting a withdrawal has indeed a balance that this contracts owe them, or this contract owes them. And when we check that this is true, we need to now actually send the amount back to them. And this is done just using the bang here. And what we're returning is the amount that they're owed. And so this operation here is now sort of polymorphic in what the type of this channel is here. And in this case, this bang is effectively a transfer call. And we can do this because we know that MS is like a blockchain address, right? If this was just a different channel, let's say a TCP port, then this is just sending an integer, right? Or we're not actually calling over to the transfer function. And I mean, just to finish it up, you have to return, and then there's the false case. But yeah, I'm just going to leave this out for now. But this is essentially how, I guess, what we've been building up so far is going to actually sort of manifest itself in user-defined contracts.
Hopefully this addresses almost in total your questions about double spend. Oh, okay. Yeah, well, give it. I mean, because you had asked, you put that on the stack of questions back when we did Dev Stand Up a few weeks ago, and I promised you an answer. Yeah, but the Casper doesn't work at the level of values, and that's what I was trying to say. That's what I was trying to say, is it doesn't work at the level of values. It only works at the level of the COM events. And the COM events, in some sense, we want to be able to obscure the values that are being pushed back and forth across COM events. And now this is the logic that prevents double spend and allows you to do all kinds of other policy stuff as well. That's right. That's right.
I'm still puzzled about the interaction with Rev, because the model I had had in mind was that Rholang would be the Rholang for a user contract would be transpiled to Rholang that interacted with the Rev contract at the user level on the blockchain. Because you can't run a Rev contract on an individual node, which is where the service, I mean, the system level contracts are running on an individual node and then communicating with other nodes in order to provide the blockchain. But Rev doesn't mean anything except on the blockchain, right? So I still don't see how Rev could possibly be a system contract. I could see that it's a user contract and everybody can verify which user presented it and everybody agrees this is the authoritative contract we're using. But it's got to be at the level of blockchain stuff and not at the level of node stuff.
The Rev contracts make use of Casper. So let's make a finer degree of differentiation. So there's that which depends upon Casper, and then there's that which depends upon Rev. And I'm arguing that the system contracts go up to that which depends upon Rev. And that's and the reason and the sort of political reasons why you want that to be controlled by the co-op. Right? That needs to be something that's set by the co-op and not just any old user can come along and change the Rev contract.
Well, they can present their own contract.
They can present their own contracts, but
nobody will interact with that contract and think that it's Rev.
Right, exactly.
So I think the point Mike is making is Rev is basically a blessed user level contract.
Yes.
Yes, it's a blessed user level contract, and that's what I was saying. Is like it's so I'm drawing.
We had been using system contract to mean that which implements the blockchain, and so it was very confusing for me.
Okay, understood. Yeah, fair enough. Yeah, it's a yeah.
I wouldn't call it a user level contract. It just happens to be above Casper, but it's system contract.
That's the way you and I think about it. But they were developing a different.
Yeah, from your diagram yesterday, yeah, it's above Casper, but now that diagram needs to be revised so that there's Rev contract and then user level above that.
Okay.
Question I have, why Rev is coming as a part of the Rholang? Our scenario that Rholang or any other currency should be
It's not built into Rholang. It's just that we're making. It's implemented with Rholang.
In the same way an ERC-20 contract is implemented.
I'm talking of the Rev, like as a token, but the solidity, I think it's agnostic, it's ERC-20 token.
So the question was, why are we implementing Rev in terms of Rholang? And I think the goal is to make it turtles all the way down. Right, like, so that, like, if we have a proof system for Rholang, then we can prove that Rev is correct, just as, and the users can prove their contracts are correct, and we can prove the system level contracts are correct.
And eventually we want to get rid of Rosette and Scala and the JVM and everything and bootstrap the compiler for Rholang written in Rholang.
Verified. Yeah, so this verified all the way down. It's turtles all the way down. At least, so the last verification step is the compiler to the metal, right? Right. So we're going to have to.
Well, we'll also need to verify LMDB and the network.
Yeah, that's correct. That's a separate set of proof obligations. But with respect to hitting the metal, you also have to. In the sort of standard layer, there's going to be some virtual machine abstraction to whatever the hardware is presenting us, and that has to also be verified correct.